Students, this is Sivakumar, 11th Standard Mathematics, Chapter number 2, continuation of exercise 2.1. Now, problem number 2. Prove that root 3 is an irrational number. Very important problem. It's a 3 marks problem. Prove that root 3 is an irrational number. Okay. Here is the question. Prove that root 3 is an irrational number. Proof. We can prove this result by contradiction. That means I am assuming that root 3 is a rational number. Assume that root 3 is a rational number. That is, you know that rational number format that is P by Q, where P and Q are integers. They don't have any common factor other than 1. I write over here, where P and Q are integers and they don't have any common factor other than 1. You just cross multiply. If you cross multiply, you will be getting P that is equal to root 3Q. P that is equal to root 3Q. So it implies P that is equal to root 3 into Q. Squaring on both sides. On squaring. That means squaring on both sides. While squaring, P becomes P squared, and if you square that root 3 square is 3, and squaring, while squaring Q becomes Q square. P squared that is equal to 3Q squared means P squared is multiple of 3, because P squared equals 3 into any expression, we can say it's a multiple of 3. Therefore, P is also a multiple of 3. For your reference, I give an example, you can understand. I take P square that is equal to 27. P square equal 27, that therefore I take a perfect square number, P square that is equal to 81 I consider. It will be easy for you. P square equals 81 means P that is equal to 9. Obviously, taking square root on both sides, P squared square root is P, 81 square root is 9. 81 is a multiple of 3, correct? Because 27 3s are 81. Then 9, P that is equal to 9, that is also a multiple of 3, because 9 itself can be written as 3 into 3. So, if P squared is a multiple of 3 and P is a multiple of 3, remember. Therefore, I consider P that is equal to, since P is a multiple of 3, I consider P that is equal to 3 times M, where M is an integer, where M is you no need to mention about M, because M can be any number or any integer or any variable. It doesn't matter, because this is a multiple of 3. So that I mentioned 3M. P is also a multiple of 3 means P can be written as 3 into M. Okay. Now P square equal 3Q square. Now we have written, let it be equation number 1. I am going to substitute the value of P in equation number 1. Therefore, equation 1 implies P, what is the value of P? 3m. 3m the whole square, that is equal to 3q square. 3m the whole square is 9m square, that is equal to 3q square. 3 table get cancelled, 3. Okay, 3 times. So which implies q squared, that is equal to 3m squared. Q squared equals 3m squared. What it means? Q squared is because 3 into any expression is a multiple of 3, which implies q squared is a multiple of 3. Since q squared is a multiple of 3, obviously q is also a multiple of 3, which implies q is also a multiple of 3. Okay. Already we have proved P is a multiple of 3. Now we have proved Q is a multiple of 3. Therefore, we can say P and Q have the common factor 3. It contradicts our assumption. It contradicts our assumption. It contradicts our assumption. What is our assumption? Here, root 3 is a rational number. We assume root 3 is a rational number. Rational number means that P and Q are integers, they don't have any common factor. So according to the definition of a rational number, P and Q don't have any common factor other than 1. But what we have proved, P and Q have the common factor 3. Therefore our assumption is wrong. Therefore our assumption is wrong. That is, root 3 is a rational number. It is our assumption is wrong. Therefore, what about the root 3? Root 3 is an irrational number. Therefore, root 3 is an irrational number. So problem number 2 is completed. I'll be teaching that problem number 3 in the next video. Thank you, children.